Good evening, everyone. I hope you had a very interesting open space sessions, and I hope you had a very interesting day today and learned a lot. And as I was telling you in the beginning of the day, I will talk now about a model for growing your career. At least that's something I've discovered, and as we know, all models are wrong, but some are useful. This is definitely wrong, but I hope it will be useful for you. And let me start by making a guesstimate. I don't usually like to make estimates, but I did this for this talk. So, how many of you have experienced these things? Yeah? It's probably 80%. I think most of our work is actually to work on existing code bases. We rarely start from, nice, well-designed, well-crafted code, right? And sometimes you change something and a completely different thing breaks. And of course you are to blame because you did that change. Sometimes you don't even understand what you need to change. So you get a bug, you get a new feature to implement, and you have no idea whatsoever what to do. But we do this while being under pressure. There's always this pressure to release more, to fix a bug, to add a new feature, and so on. And that's the natural environment where most of us live. And because I noticed this, I think that change is the most important thing that we do as developers. Changing code. This is what we do. So I built this model based on 5 different levels of, let's say, how good you are with changing code. Well, let's see if you find it useful. As I said, all models are wrong. Some are useful, so I'm sure this is wrong. And one of the things I know. I don't talk about soft skills. Soft skills are very important. It's important to be able to work in a team and so on. But this is more on the hard skills. So that's by design. And I'm sure there will be some discussions later about how this affects the model. So first level, I write code but it doesn't work. I think we've all been there, right? I'm going to show some examples. This is my favorite one that I've seen. This is code that I used to write. Unfortunately, I don't have some of my old code from back when I was learning C++. Okay. But I found this on the internet, and I realized, so I remember writing this type of code. So this was a question, I think, on Stack Overflow, but basically nothing worked as it's supposed to. And it's pretty normal when you learn a new programming language, when you learn a new technology, when you start with programming, when you have no idea what programming is about, this is probably what you'll write. Of course, it's now a bit easier with new and cool programming languages that make it easier for you. But you can still make this type of mistakes. And you don't need a lot of skills to do that. And maybe you remember the type of discussions we used to have, like, it's 90% ready. 90% done. I'm almost there. Or when the tester comes to, I did that. The tester would come to me and say it doesn't work. And I say, well, it works on my computer. Um, yeah, the other types of things, like it worked yesterday. Yesterday it used to work. I don't know what's now. It's strange. And the third one, that actually happened to me. So, but the strange thing is that I caught that in a code review. Basically, I had a colleague who had to implement a feature of downloading from a web server. And instead of doing that, she did network copy from a computer that was hard-coded as, let's say, Jane. Okay. This wouldn't work anywhere else, but it might work if the client had a computer named Jane in their network. So it's a pretty pesky issue. That's kind of the code. So let me explain that for those of you who didn't live the glorious C++ days. I once hunted 6 months for a bug. That's a real story. And what would happen is sometimes when you would go in the user interface, you would get a memory, basically a crash with a very helpful message, kind of memory error, FFFFFF. That was very, very useful. You couldn't find where was going on. And I had no idea why this happened. It was only happening sometimes, not all the time, so I couldn't reproduce it. I had no idea why. And it turned out, after 6 months, that I was using the wrong type. I was using int instead of unsigned int. And sometimes I would get kind of a message from the Windows API that was exceeding this type. But only sometimes, not always. So this is the kind of code that you write when it sometimes works. Now, back then, I knew how to write code. I was passionate about programming and I wanted to learn more. But I realized that there's something wrong with it. I mean, if I'm introducing these types of bugs, I'm missing something. Because these are the worst bugs to have. Very hard to find them. But I persevered, and hopefully it's better now. So I think the next level is I write code and it always works. Well, of course, when we say always, it's like the engineering thing for always, which is 90% of the time. Yeah, sometimes, of course, we all do mistakes, okay? But I had colleagues that you knew, whenever they were touching code, you knew that nothing was wrong. You knew that maybe once a year they would get a bug. Maybe once a year you'd get something that was not quite right in their code. And, well, they call them usually senior programmers, but I think they should be called programmers, because that's when you start being a programmer. At least that's my belief. And sometimes they write code that looks like that. It's something that works, okay? But when you look at it, especially as a junior, the other levels that we talked until now, they won't get all the things that they are using in the code. And I used to write code like that. Here I took this from internet again, but unfortunately, because I don't have some of my older code, because then I could give you some samples from my code. And I used to write code like that. It didn't look quite right, but it did work. Now the problem with this one is, even if it works, it's hard to change afterwards. Especially when you are working in a bigger team with various skills, various experience, and so on. It's not easy to do that. But here you need to have some skills, more useful, let's say more hard skills. You need to understand what you're trying to solve, because otherwise you won't implement the right thing. You need to be able to ask questions, clarify requirements, identify technical risks. Whenever you change something, you need to understand what other things change. So it's all getting more difficult. You need to test your own code, because waiting until the testers do it and then getting a bug, then you're not really doing it. You're not really at this level. So it might happen that this is the time when you learn about things like automated tests, or you're doing reviews, or you're doing pair programming, things like that. Now the next level, which is, I think, what we want in most cases, is I write code that not only works, but is also easy to change. That's already harder. It's more difficult. I think they usually call them technical leads. I don't know if we still use this term in the industry, but that's what I used to. And they write code that's much more expressive, let's say, that expresses what the code is supposed to do much easier. It might still need improvements. I mean, it's never perfect, but it's easy to read. It's probably easier to change. Maybe it has some tests behind, and it doesn't try to be smart, let's say. It tries to be understandable. It tries to be readable. And that's one thing I learned the hard way, because I used to write code that was smart, and then not understand it later on. And I think that at this level, you start having the need for design skills. Because writing code that's easy to change doesn't require only to write expressive code, but also to find out how to organize your code so that it's easier to change. Automatic developer testing, it's hard for me to see how you can change code easily without having these types of tests. Maybe you can. Now the fifth level, that's really kind of the one that we would like to have in many organizations. Whenever you have inherited a big pile of code, a large solution written by people
from the level 2,
from other levels, and then of course you need to solve bugs, but you also need to add features very quickly, and now it's your problem. It doesn't matter what the others have done. It's your problem to do it faster. So what are you doing now? And it turns out, I used to think that level 4 is enough for that, but it's not. It's much more difficult. And usually it's a consultant, or recently J.B. Rainsberger wrote a blog post where he says that we should call these people code cleaners. People who are able to take bad code, turn it into code that's easy to change, so that other people can then add features very quickly. And the reason this happens is because you need additional skills. There is not only unit testing already. It's not only, even if you know test-driven development, unit testing, pair programming, continuous integration, you master all the practices, you know refactoring, you know design. Still going to that level where you can turn bad code into good code, it requires additional skills. And some of the skills are this: writing tests on existing code. We get this question a lot. So what do I do? How do I do TDD on existing code? That's my favorite one. Well, you first have to clean your code and then do TDD on the new features and so on. But in order to clean your code, you need to know how to write unit tests, you need to know design, you need to know refactoring, you need to know specific techniques for writing tests on that code, you need to know how to break dependencies, and so on. It's already a much bigger step, and that's what Michael Feather's book is all about. So I highly recommend you to read it if you want to get to this level. You need refactoring, and sometimes when you have a very, very big code base, that's when you need to automate the refactoring, which is an even higher step. That's when I first heard of it, I thought that's crazy, but you can actually do this. And there are people who are able to come into a code base, look at it, analyze it, fiddle with it by refactoring it manually, automating refactorings, and then applying it on the whole code base. And at the end, you get quickly to a point where it's already much better. Now you realize that this requires additional skills. You must be either a very good Vim guru and write Vim scripts for that, or you have to be some guy who understands programming languages very deeply and know how to do abstract syntax trees and all that stuff. It's already a next level. So this is the model that I came up with. And I think how you could use it. You could use it wherever you are. Yeah. I tried to give you some of the skills that you need to learn so that you can get to the next level. And as you have seen, if you want to become a consultant, that's where you need to be. That's where the money are. Okay. Well, quick reminder, of course this model is wrong, but I hope it's useful. And maybe it's also useful for you if you are a technical lead or a manager, or kind of look at the developers that you have and figure out on what levels they are, and figure out what it takes to move them to the next level, and actually to figure out what level you need in your company, because not everybody needs the 5th level. Okay? If you're lucky enough and just work on new stuff, then you don't care about turning bad code into good code. You care about writing
Bad code.
bad code. Second level is enough. Yeah. Okay, so that's it. Thank you, and if you have any questions, I think we still have some minutes left.
How do you become level 5?
How do you become level 5? That's the question. Depends on what level you are. I would say by going through all levels, at least this is what I noticed. Okay, so in order to become level 5, you need to understand things like design and things like refactoring and unit testing and so on. And I think it's much easier to learn them one by one. It's easy to say I will start doing all at once, but from my experience, trying to get in place all the practices that you learn, all the techniques that you learn from dealing with legacy code book, Michael Feather's book, that's very hard unless you understand design, unit testing, refactoring, and all that. So I would advise you to go through these levels. These have come from my experience. Other questions?
Do you have an example for automated refactoring?
I haven't done it. Okay. I'm not at that level. But I know, I've talked to people who, there's, I know Eclipse, for example, allows you to write scripts. So you could automate your IDE to use the refactoring from the IDE. But first of all, you need to identify patterns in the code, so things that need to be refactored. I think that's the hardest part, actually, figuring out which are these. And the best way I know to do that is to use Mikado method. I don't know if you are familiar with Mikado method. Okay. So the idea with Mikado method is to try start from a code base that, of course, that's bad, and try to refactor it in a certain direction. And the problem is often there are so many dependencies that are not quite right and that influence each other. So how do you make sure you do the refactorings in the right order? And the Mikado method basically says you start by doing refactoring, and whenever you get stuck, you go back. And then you go further again on another path, and then you go back, and then you do it again on another path. It's an exploration because you have no idea where you are going. And what they advise is there's a book on it, and again, it's highly recommended. What they advise is to build the scripts for refactoring as you go, so that you are able to basically play back and go back and forward with automation. And one way to do that is using Vim scripts, which, yeah, there's one. The other one is to automate your IDE, both Eclipse, Visual Studio, you can do that. Use the refactorings from your IDE. And yet another one is to write your own very custom refactoring scripts, which means you are very good at parsing languages, and but that requires a whole other set of skills. So it's not an easy task. That's why I'm saying it's really top-notch. But once you do that, the interesting thing is that you can apply on a very large code base. And there are much more chances of getting it right fast. Any other question?
Yes, you mentioned the book.
The book? So I mentioned 2 books. One is Working Effectively with Legacy Code by Michael Feathers. It's an older book, mostly with C++ examples, but the techniques are very valid. Techniques are very useful. There's another book called Mikado Method, which discusses the Mikado method, but it doesn't give you the technique for breaking dependencies. You still need to use the techniques from the other book. And also, a very nice way to practice is during a legacy code retreat. A legacy code retreat is a community event where we start from an existing code base, and we focus on we work in 45-minute session, and in each session we focus on 1 or 2 of these techniques for removing dependencies. But you need a lot of practice to actually. Maybe we can make some session tomorrow at Open Space on some of the techniques. There are many techniques.
I showed one today.
Okay.
From nothing to system.
So Adi showed one during the Open Space, but I'm sure we can do tomorrow another one. My advice is anyways to practice. So read those books, but also practice. Is not enough to just read them. Any other questions? Okay. Well, thank you.